Hi everyone, this is Mahavir. I'm working in Sri Venkateshwara College of Engineering, Bangalore. Today our topic is engineering electromagnetics. In short, I will call this as EE. EE is a branch of physics which is dealing with both electric and magnetic fields and their phenomena. The complete analysis of these two fields will be discussed in this particular concept. So these two fields and their applications and their analysis is vast in this real world. There are many applications, like for example, in the radars, in the communications, in the satellite communications, everywhere we can see the applications of engineering electromagnetics. So basically, there is a small difference between the network theory and the engineering electromagnetics. If you go for network theory discussed or deals with the with some parameters like voltage and current, which are scalars. Whereas if you go for EE, it is a branch, it is a science which deals with the some fields like some parameters like electric and magnetic fields, which are literally vectors. So that is a major difference between the network theory and the EE, in fact. So today we want to discuss. I like to discuss about the much elaborately about the analysis of the fields. What is the force between the charges? What is the force between the two particles or whatever? So for that we will go for the topic called Coulomb's law. So today we're going to discuss Coulomb's law. So now I'm going to start Coulomb's law. What is Coulomb's law exactly? Yeah, Coulomb law. See, Coulomb law. What is Coulomb law exactly? We'll discuss today. See, suppose if there are two charges, these two like Q1 and Q2. Q1 and Q2 are the 2 point charges. So you know very well what is a charge. So usually what will happen here is two charges can be attracted to each other or can be repelled by themselves. So the attraction, whatever the attraction or repulsion, there will be acting through a force, and these force is considered and calculated by Coulomb. So the Coulomb law states that the force of attraction or repulsion between the two charges. So in brief, the definition of the Coulomb's law is like this: the force between the 2 point charges. So here I mentioned force between 2 point charges depends on, is equal to or proportional to the charge values, multiplication of the two charge values by, is proportional to multiplication of two charge values and inversely proportional to the distance between the two charges. So for that we have a formula for that. So force is a vector actually. So we have two quantities in the universe. Like for example, we have a scalar quantity and we have a vector quantity. Here we have a force is said to be a vector quantity. So what is the difference between the scalar and vector is very simple. A scalar quantity contains only magnitude, whereas vector quantity contains magnitude as well as direction. So for example, if we take acceleration or displacement. So displacement or acceleration, these are said to be the parameters which are having some quantity as well as some direction. In the similar way, force is also having the quantity which is called magnitude as well as direction. So force, always the vector is represented by F bar. So this is the notation in which to represent a vector when compared to the actual scalar. For example, if we take scalar quantity like voltage V. So voltage V, we are not keeping any cap or any bar over representing the voltage notation, because it is a scalar. It contains only the magnitude. Like for example, 5 volts, 6 volts. It's just a magnitude. It doesn't have any relation with the direction. But if you go for a force is a vector quantity, it should be represented by the cap. So force is equal to, as I said before, it is directly proportional to the value of two charges. So here we have two charges here. Q1 is one charge value and Q2 is other charge value. So Q1 and Q2, the multiplication of two charge values, and the force is directly proportional to the multiplication of two charge values and inversely proportional to the distance between the two charge values. So here R we are representing as distance. And if you come to the units for this force, usually if you're representing a vector, there should be a unit vector with every vector notation. So without unit vector, we cannot complete the equation or a formula. So the units for here is newtons, as you know everyone. The units for the force is newtons. And if I want to change this particular formula, so we have something like this: F bar is equal to K into Q1 Q2 by R square into A. This is called unit vector, and the force here is newtons. So now this is the formula which we got for the Coulomb's law. Okay, what is K exactly? This is called K is called proportionality constant. K is called proportionality constant. It is having some value like K is equal to 1 by 4 pi epsilon meter divided by Faraday radians. So this is the unit for the K. Here I want to discuss the epsilon. What is this epsilon? So epsilon is called permittivity. So what is exactly permittivity means? Permittivity is nothing but, it is a metric, it is a measure in which any substance can hold some amount of electric energy into it. So that is said to be the permittivity. If you go for permittivity, this epsilon can be derived, can be defined much elaborately like epsilon naught into epsilon r. Whereas epsilon naught is said to be the permittivity of the free space, and whereas epsilon r is said to be the dielectric constant or relative permittivity. So if you go for epsilon, we have a units for epsilon like Faraday per meter. We have a unit for epsilon like Faraday per meter. Yeah. So epsilon is equal to epsilon naught into epsilon r. The units is Faraday per meter. Here, epsilon naught we just told before, like this is called absolute permittivity of the free space, and it is having some value. Epsilon naught is equal to 8.854 into 10 to the power minus 12 Faraday per meter. The actual source of this value we are not discussing here. We're not discussing here. If you go for epsilon r, now here we are considering the air as a medium to make this epsilon to be solved. So epsilon r for which is called relative permittivity for the air is equal to 1. So if you substitute, so literally if you take A for air, epsilon is equal to epsilon naught. So this is the value for actual value of epsilon for air as a substance. Now if you substitute this value here in K, so you'll get K is equal to 1 by 4 pi into epsilon naught meter divided by Faraday radians. Because pi is so pi we can measure in the form of a radians. So we have K is equal to this value. K is equal to, you know very well, 1 by 4 pi epsilon naught. Epsilon naught, see the value here is 8.854 into 10 to the power minus 12 Faraday per meter is substituted here. So literally, if you substitute this value 8.854 into 10 to the power minus 12 and pi, you know very well, we have 3.14. So you'll get around K is equal to 9 into 10 to the power 9. So 9 into 10 to the power 9 is the value we'll get here. So 9 into 10 to the power 9 is the value we'll get here, and the units for this here is completely opposite to their to this value. So we got the units here, nothing but meter divided by Faraday radians. So meter divided by Faraday. So this is in brief about the Coulomb's law, but the Coulomb's law is not yet completed yet. So I want to discuss much elaborately between the charges when they are in two different points. So for that I want to reframe this Coulomb's law in a different way. Like for example, so now how I define the Coulomb's law if there are charges between two different points. Let's take the points here. We have a Q1. Q1 is a charge in point P, whereas Q2 in the other point, point Q. Or for your simple understanding, PR. So R is one point and P is other point. So what is this point exactly? See, I told very clearly the vector, the fields like electric and magnetic fields are also depending on the spatial variables. See, if you take anything like for example electric field or magnetic field, they have a dependency with the volume it is occupying or the space it is occupying. So that's why we have three coordinate systems which we are dealing in the electromagnetics. Like for example, we have a Cartesian coordinate system, we have a spherical coordinate system, and we have a cylindrical coordinate system. But however, we are discussing all these phenomena as of now. In this particular session, we are discussing only with the Cartesian coordinate system, or it is also called as in simple rectangular coordinate system. If you understand the rectangular coordinate system, say for example, usually if you take we have a three-dimensional axis. This is said to be the rectangular coordinate system. So here we have three different axes like x-axis, and we have a y-axis, and we have a z-axis. Usually these every axis or every direction is perpendicular to each other. For example, if you take this whiteboard. So here also we have three-dimensional. We can assume we can keep this particular body object in the three-dimensional space in a rectangular coordinate system. How? So for example, if we take this particular whiteboard, so whiteboard we can measure the length of the whiteboard and the height of the whiteboard. Or if we take a rectangular, we have a length and we have a breadth. So length will come in the one axis, like for example x-axis, and breadth will come in one more axis like y-axis, and there is other axis which is nothing but which can be defined, which is called spatial axis, which is called z-axis. So the direction we have, if you consider this is x, if you consider this is y, for that I write for your simple understanding here I'll keep y. So the length of the board, if you consider the x-axis, the height of the board is y-axis, and the spatial direction in which pointing towards you is the z-axis. So this is how the rectangular coordinate system works. If you go for spherical and cylindrical coordinate system, their phenomena are different, their coordinates are different, their points selection is different. But as of now, if you want to understand the Coulomb's law, in this particular session we'll discuss only in the rectangular coordinate system. So in that matter, so now here also we are discussing there are two charges which are in rectangular coordinate system or in a rectangular room for that matter, which is having the link with all the three axes. So Q1 is placing in some point. If you take a room, one point is said to be like P, other point is said to be like Q. Any 2 points between in a room, for example. So P, the position of P is x1, y1, z1, and the position of Q2 is x2, y2, z2. So what the Coulomb's law tells, very simple, like for example, there are two charges, these two are the charges, like for example, you know very well, if there are two exact charges, like for example protons, so what they will do with the same charges, you know very well, two equal charges will repel each other, right? And if there are two, like for example, one positive charge and one negative charge is there, they'll get attracted to each other. So if you consider that, usually we have a negative charge. For example, electron is said to be considered as a negative charge. So electron, what is the nature of the electron? So whatever the force, the force of attraction, electron is a part of the force of attraction. So it attracts the forces. Whereas if you go for the positive charge, the force is repulsive. So this is how the charges works out. So based on this nature, there is a force of attraction and repulsion between any two charges. And the force is literally defined by Coulombs. So that is what we are discussing now. That too in the rectangular coordinate system we are discussing. If that is the case, if that is the case, let's have a q1 at a point P and we have a q2 at point R in the rectangular coordinate system. They can be anything like force of attraction or force of repulsion. So what is the force? What is the force exerted on the q2 because of q1? We are calculating now. So there is a possibility of force exerted on q1 because of q2 also. That particular definition of that particular formula we can also write. So now, as of now, we are discussing about force exerted on q2 because of q1. So very simple, like for example, force from P to R. So force from P to R. So this is the force representation, for example. So the force exerted on q2 by q1, I'm writing as in this notation like suffix P to R. So which is equal to, as I said before, the Coulomb's law. So Coulomb's law is equal to 1 by 4 pi epsilon naught. Why epsilon naught? Here I'm specifically saying epsilon naught because the medium between these two charges can be anything. Here we are considering air is a medium. If you consider air is a medium, so epsilon naught, we already discussed, epsilon is equal to epsilon naught into epsilon r, whereas epsilon r is equal to 1 for free space or for air. So now 4 pi epsilon into q1, the value for charge q1 is q1 itself as of now, and the value for charge q2 is q2 itself, divided by, we already told the force is inversely proportional to the distance between those two. So usually we have the formula, we call the formula 1 by 4 pi epsilon q1 q2 divided by r square. So here r I'm representing specifically as the distance between P to Q, sorry, P to R. So PR bar whole square. So this is the representation to find the value of the r square or just r. So now we have one more parameter which is called unit vector. So unit vector here is, so A, PR, I'm just, instead of keeping as it is, AN, I'm keeping as A suffix P to R vector. So this unit is Newton, simply we can write as N. So now this is the formula for the Coulomb's law, especially if there are two charges, the force between the two charges when they are in the rectangular or Cartesian coordinate system. If you see carefully, if I want to expand this formula much elaborately, I want to know what is PR, how can I calculate PR. So what is this PR, usually PR bar. So PR bar is nothing but a distance. So usually this value can be calculated with some mathematical things. So how we can able to calculate the distance between the 2 points? In the similar way, we can find the value of PR also. So for that matter here, the force is exerted on the Q2 because of Q1. So the distance between here to here can be calculated by PR bar is equal to square root of, we can write as x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the basic mathematical formula to find out the distance between 2 points. The same we applied here to get the PR bar. So PR bar is equal to, this is the formula. If you go for PR square, so double side we are multiplying with the square. So this square root will be, yeah. So here there is a small correction here. If you go for PR vector, so PR vector it is a vector quantity, but it defines in the scalar form. That's why you should be very careful enough. Like PR, it is a magnitude, and this is the representation to get a magnitude for any vector. So that's why, so PR, this is a magnitude representation of PR vector, so which is equal to x2. This is the distance, nothing but a scalar quantity. So this is how you should get the distance between the 2 points or between the two charges. And now if you go for a unit vector, so unit vector, I told very clearly, if you take 100 rupees, for example, what is the unit for 100 rupees? What is the basic? So for 100 rupees, whatever the 100 rupees it is, the basic unit is 1 rupee. So here 100 is a magnitude, into 1 is the unit actually. So here also in the similar way, we have a vector, we have a unit vector also, which is represented as a bar, PR is a suffix. Okay, so this how can we define this unit vector much elaborate? Like for example, so a unit vector is equal to, This is actual vector divided by magnitude of the two vectors. The actual vector, actual PQ bar is a vector actually, and divided by magnitude of the vector. Because I said very clearly, force is acting between the 2 points, and the direction in which we are uh, we are assuming is the direction is from P to R. So that's why the unit vector is measured like the actual vector between the 2 points, PR vector divided by magnitude of magnitude between the two vector. So if that is the case, what is how to get this value PR bar? So PR bar is very simple like so here. See, for example, if you take a force, in this example, the force is moving from P to R. The force is moving from P to R. So that means the force is moving from x1 to x2 in x direction, and from y1 to y2 in y direction, and from z1 to z2 in z direction. So that is represented in the form of a vector, in fact. So here PR bar we can simply represent it as like this rotation x2 minus x1 ax vector, because the difference between the 2 points, the actual magnitude in the x direction, x2 minus x1 into ax vector plus y2 minus y1 ay vector. See the difference in which the force is moving from one point from y1 to y2. So the difference, always the destination minus source will get the actual value. So y2 minus y1 into ay vector plus z2 minus z1 into az vector is the PR bar value. And what is the P? What is the this is the magnitude. This is the vector. You should be very careful. Like PR bar is a magnitude. We don't have the modulus symbol here, sign here. So this is called the magnitude. And this formula we already discussed here. This is the same thing we can apply here. So this can be x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now, so this is the different values we got from the unit vector and the distance. So if we apply these particular formulas in this equation, the equation will be modified further. Like for example, I want to change the equation. The same equation, the force equation, this will change as, so this will remain as it is 4 pi epsilon naught. I said very clearly epsilon naught is nothing but permittivity, absolute permittivity in the free space, because we are considering the two charges Q1 and Q2 are in the between the free space, and so Q1 as it is Q2, and we already discussed this one unit vector. We already discussed like APR vector is equal to actual vector divided by magnitude. Okay. So this is the formula we just now discussed. I just replace this with this equation. So when I replace this will become PR bar whole square into actual vector between the 2 points divided by the magnitude, newtons. So now, if you change this, you'll get like the force between, according to Coulomb's law, the force between the two charges, the modified formula is 1 by 4 pi epsilon naught Q1, Q2 are the values, the units of Q1 in each charge values is coulombs. So divided actual vector divided by magnitude bar whole cube, because these two will get multiplied and will get whole cube newtons. Yeah, so I want to much elaborate this one. Okay, so here we have a P, we have a R. So here usually we'll do some mistakes, like for example P and Q, there is a small confusion. So what I want to say is so P and Q, it's not Q literally, it's R. It's R is nothing but the destination in which your charge is located. So always you should the other value is nothing but PR here. So this also PR. So PR bar is nothing but the distance between the magnitude of PR bar, nothing but distance between the two charges placed at P and R.